Guys, this is Expert Honda and you're watching on YouTube. So let's understand today's question. Today's question is 2300. Okay, so the question is saying that successful pair of spells and potions, right? So there is saying that successful pairs, right, of spell, and there is some spells, right, and some potions, right? What is that? Let's understand. So let's read the question from here. In which it is saying that you are given two positive integers, that is spell and portion, right? So two integer array we have given, that is a positive integers, right, n and m respectively, having the length, right? And it's also saying that a spell at I represent the strength of ith spell, and portion of j represent the jth portion. So you are also given a success, an integer success. So a spell and portion pair is considered successful if the product of their strength is at least success. So return an integer array pairs of length n, and where pairs of I is the number of portion that we that will form a successful pairs with I spells, right? So question example is saying that first we have a spell, and this is a 513, and portion is this, right, and success is this thing. So as the example is saying that we have given first two integers, right, array. So that is a spell, and it is giving 351, and another portion given this one. Now its length can be n and m, that's another thing, and have spell and portion given. So now you have given integer success, and success we also have given here. Now it is saying that the spell and portion pair is considered successful, correct, if the product of the strength is at least success, means product of their strength is at least success. So what does it mean? Let's understand. So return an integer array pair of length n. We have to return an integer array pair of length, right, where pair of I is the number of portions that will form a successful pair. Got it? No, means in the pairs we will return a pair of you can say a list of integers, that is called you can say array element, right? So these elements are nothing but pairs, right? So each pair is nothing but a number of portions, right, that will form a successful pair with ith spell. Okay, so it is saying that we have given 403, right, and sorry, this is the output. So how it is coming? So we have given a spell, we have given portion, we have given, and success we have given, and then we have to return 403. So how it is happening? So in the first spell it is saying that we will multiply this 5, right, with the whole portions, right? We will multiply, because this is not nothing but a portion is we have to do a spell and portion pair is considered successful only if the product of their strength is you can say at least success, right? So if you want to do a successful you can say right, pairs, right, in that case you have to do the product of their strength, and that is called a success. Okay, so what we will do here, we will return an array of pair. How will it come, right? So it is saying that first we will multiply at 0th spell, we will multiply, because 0th means 0, 1 and 2, this is the index. So we have to multiply with 0 with these portions, then we will multiply with 1, and then we will multiply with this one. So it is happening like this. So in the first explanation is then it will multiply 5 with this one, and it will become 5, 10, 15, 25, right? So 4 pair are successful. Why? Because see, 10, 15, 20 and 25, right, these are you can say a product of their strength we have, right? And if we will take you can say this one 2 1 at 1, so it will become 1 into this one, because at 1 the value is 1, right? So it will remain same, and so there is no any changes happen here, right? Now it will take 2 at index 2, we will multiply 3 into this. So now it became what, 3 into 3 and 3 into 4 and 3 into 5, right? So 3 multiplication it happen here, right? And it will become what, this 3 pair, right? So now if we'll combine this one, right? So first it will become what, 4, so we'll put into 4. Second it will become what, 0, and third is 3. So this is the value we have to return. I think you got it, right? Means the question you got it, right? Now understand example 2. Similarly we have given spells, right? 3 1 2. Now we have given portions, right? And success, right? So first time we'll start with 0 1 2, right? 3 times we will do the multiplications, right? Like this, 1 2 and this one. So all the elements will get multiplied. We will get the respective values. 24 24, right? It is coming, and these two you can say pairs successful. And if we'll talk about here 1 into this one, so there is no any changes. Similarly we are multiplying 2 into 8 and 8, right? So it will become 2 pairs, right? So why the question asked, this question has been asked in Goldman Sachs and top companies, right? So I have just taken this one. Now if we'll talk about the similar questions, so the similar questions we have is most profits assigned work, longest subsequence with the limited sum, and the maximum matching of players with the trainers, right? So if we'll talk about the solution, right? So we have given two arrays, right? Spells and you can say portion, right? So we have 3 1 2, and we have similarly 5 2 1 1 2, like that we have value because there is a success is 10. Okay, so we need to find for each spell how many portion will form a successful pair. So pair, you can spell pair, portion, right? A spell and portion pair is considered successful if their product of their strength is at least success, right? So if you see here, right? So 5 is the product of this one, right? Similarly we can see these right, these elements. So there are multiple elements you can see that is you can say coming a spell, right? Because see we have 3, and if we multiply here sorry, if we multiply this will become like this one, right? Similarly if we'll do the sorting and binary, right? So we have a spell this, right? And we have success, and this is a portion of the array, right? If we'll do the multiplication, right, it will look like this one. So let's say current spell is 3 and minimum will be sell 10 by 3. So the selling value will take 3.3 is nothing but 4, and so all element greater than or equal to 4 will result into successful pair with a spell 3. So the first index bound is portion array 4, and the total number of the portion will be form a successful pair with a current spell at you can say 15 minus 4, that is 10 11. So we are here, and we are going to understand two things. First of all, we have given spells and portion, right? So in this case what we should do, first of all we'll do sorting of the, you can say, portion, right, of the array, right? So that we will have our in the increasing order we will have the portions, right? And to do that, what we have to do, we have to find we have to do arrays, and we'll do arrays dot sort, right? Now once we will do arrays dot sort, we will have our element. I'll do portion here, right? And then what we should do, we will take int, and we'll say arrays and the element, right? So if we will have our element, right, so what we should do, we'll take one result, I will store there, right? So I'll take result, and this is nothing but our, you can say, array. Okay, so this array will store you can say its value. Okay, we will take its value, and so that we can say how we'll do the array initialization like this, right? So it will store PS spells, right? On the spells we'll do length, and we'll get our size. So this is done, and after after this, what we should do, we should find a max portion, right? And to find the max portion, what we have to do, we have to take you can say variables, right? And that is nothing but max and portion. Okay, so the max portion will find from where we have portion, right? On the portion yeah, on the portion we have element, right? So this element, what we will do, okay, I have did little mistake here, spelling mistake. Okay, I think this is not portion, this is portion. Spelling mistake, because that is given portion. Okay, and this is not portion, it's portion. So max portion I will do next portion, right? So on the max portions, right, positions, you can say portion, right, is given. So we'll take what we will have our portion, right? And from the portions dot we'll do length -1, right? We will get our max portion value. Now what we will do, we'll take you can say loop, and this loop will start from where, int I to 0, and we'll go to its you can say I should be less than what, we can take spells, right? Spell dot length and I plus plus, correct? Now what we should do, we should find our spell. Now this is our spell. So this spell is nothing but our spells at what some value is there, right? So I'll pass some value. Once you got your spell, right, now we have to find minimum value of the portion whose product will be the current spell. What minimum value of the portion whose product will be the current spell, right, with the current spell, and will be the least success or more. So to do that, what we have to do, we have to find a long, and we'll say mean portion, right? So if we have the mean portion, we'll find our what, we'll take a math dot selling value, right? We can find our selling value, and here we will pass two things. First 1.0 into success, right? And we have given this success, right? We have this success, right? Now after getting this selling value, we will divide by what, number, right? Like this. Actually, after dividing, we'll get our you can say selling value, and the selling value will do what, will define long. If this is long, this will return your long value. Okay, I think this will work. Now what we should do, see, we have to check if we don't have any portion which can be used or not, right? So to do that, what we have to do, we have to find our mean position. If mean portion you can say, or position you can say, if is greater than max portion. If it is greater, then we will make the condition check if we don't have any portions which can be used. So in that case, we will have our result. So this result will store our element. So I'll take initially as 0. If not, we will continue like this. Okay, so now this is done. We can use the bound portion and all the portion in its right. The right portion are greater than the found portion, right? So to do that, what we should do, after completing this one, we should use index. We have to find our, you can say, index indx. Okay, and this index will store what? Lower bound function. You can say, let me do like, I'll take a lower bound function, and this function will take your portion, and it will also take your you can convert into now into integer, and this is nothing our because we have converted into long, right? So now we'll convert into this one. From here you will get your result. So to get the result, we have to enter I, and at I you will pass what? M minus, M is nothing but, you can say, length, right? So you can take spell dot length, right? Or you can say portion length, you can say, right? Portion dot length minus, you can say, M minus 1 you can take, and then you will do index, this one. And once this is done, you will return what? Here. Before this you will return here, and this is nothing but our return what? Result. Okay, now what we have to find, we have to make lower bound. So this function we have to develop, in which we will take portion and this one, right? So how will make? To make this one, we'll make its body first, right? And we know that this function will take what? Two things. First it will take you can say array, and another is its key, right? So it will return our integer. So first of all we should give integer as a return type, and then this portion is nothing but your array element, right? So I'll take into array, right? And this is our portion, and mean, this is the mean, right? So minimum portion we have to find, and this is also int, correct? Now first of all we'll take int low. A low will start from 0. We'll take a integer high, right? And this high is nothing but our you can say portion. We have portion, right? Dot length. I think you got it. Okay, once this is done, what we should do, we should make a while loop, and we'll traverse from low to high, right? And to do that we'll do low, and this is our high. And once this is done, what we should do, we'll find our int mid equal to, you know that what I'm doing here, right? This is nothing but our binary search, right? And we'll find our to find the mid, there is multiple ways, right? So you can do high, sorry, you have a high, so high minus, you can do what? Low, right? And you can add low also here, low, like this. Okay, you can do low plus what? High minus low, and then you can divide by 2, right? In binary search we discard the other half, right? How? If the search element at what? Portion, if we have to find the minimum search, right? And if this is at what? Mid, means if not, right? If not, in which case, and we'll take what? Our mean. If mean portion is not at this position, right, is less than, it means we have to update what? Low equal to now mid plus 1. So other half, first half we have to remove, and then we'll take another condition and we'll say else we'll make another half, and this is nothing but you have to make you can say, and you have high, so high is at what, minimum, means we have to discard next half. Okay, and then once this is done, so this is your this one function, and this is our return, right? So before that we have to return here, you can say low, right? So return low now, because minimum we have to return. Let me run this one. Okay, so what I have did, I will explain here, so no need to worry about this one. Okay, so the technique that we are going to use is sorting plus binary, right? Binary search. So in the sorting, which you can see, we are using what, arrays.sort, right? And after sorting we will find what, minimum portion, right? And then we will, each time if you find our minimum position, right, if minimum position is greater than this position, we will put 0 value. If not, then what we will do, we will find our minimum portion, right, in this portion. So this minimum portion we will have from here, right? And using the lower bound you will get your lower index, and we will store the lower index here. So from the length, right, max length minus, you can do the current index, last index minus this index, you will get your result. Okay, and finally we will return. And to find the lower bound, what we are doing, we have our portion. From the portion, what we will do, we'll pass our minimum position, mean portion, right? And from there what we will do, we'll do low and high. We know that this is our binary search, right? And we'll get our we'll reverse till low to high, we'll find mid, and we'll, after finding the mid, we'll check the search element, that is our mean portion. If it is less than the at mid, means we have to update our low, mid plus 1, first half we have to discard. If not, the second half we have to discard, right? And then if we will get our value, we'll return this one. Okay, so I think the process is nothing but very simple. Okay, you have to find your mid, right, each time, and then we have to discard. So actually what we are doing here, right, see what actually we are doing here, we are doing what we'll do, we are doing the sorting the portion array in ascending order. Okay, and after that we will define whatever required, like max position required, result is required, then we will do that, right? And for each spell, right, for each spell what we have to do, we have to go into the loop, right? And then we will calculate the minimum portion, right, minimum portion. So to calculate the minimum portion, right, strength required, you can say, to make the spell successful at minimum position, right, mean portion, you can say, using the formula, this selling we will take selling value of success by spell, and whichever we call, that is called our minimum portion, right? So if the mean position is greater than the max position, right, we will store what, 0, right? So in the result array, and we will continue to the next. Okay, means what I'm saying, to first of all we'll take our mean portion, right? So to we will calculate the mean portion strength which is required to make the spell successful, right? So as the mean portion will calculate using what, this function, right, math.selling value, this is nothing but our success, right? So success by, you can say, we are doing a spell, and whichever it is coming, will take our what we can say, this one. Okay, 1.0 into success we are doing. So why we are doing, actually we are calculating value and then we are dividing, right, this one. So this is actually the formula, you can say, to find the mean portion, right, using selling value. And if the mean position is greater than the max portion, right, in that case what will happen, we will store 0 into the answer array, and we will continue the next spell, you can say. Otherwise what we will do, we'll find our index, right? We will find our index of the first element in the portion array, and if it is greater than or equal to the min portion, using the inbuilt lower function, right, that we have developed this here, right? So from here we'll get our index, right? Then what we will do, we will get our index, we will find our index of the first element in the portion, right? And that you can say is a greater than or equal to the min portion, right, using the inbuilt lower bound method. Like you have lower bounds, we have, right? You can call this one, right? And so this function, you know that this is our binary search. From the binary search you will get our lower bound, and this will work, right? And we will calculate the maximum, you can say we will calculate number of successful pair in a spell, and we'll do what here, actually we are doing here, okay? We are doing what, we are calculating the number of successful pair possible for the current spell in m minus index. So this is your m is nothing but, you can say, size of portion, right? This is your size of portion, okay? And we are dividing minus 1, right? Some people also say n, right, because n is the length of, you can say, of your spell, okay? And then you will return your result. So you can think about this question once again. You will go revise this one again, what we have discussed, and then you will do some hands-on. Let me run this one. Now it is coming high, mean. Have I started mean? Yeah, we have taken mean, right? So cannot find the symbol mean. Oh, sorry. This is our nothing but our line number 29, right? I have taken mean. I'll put here. Okay, it should work now. Okay, so answer is not matching. Why will happen? We'll take our answer is this one, and we'll put the, you can say, length and minus index. I think we have to remove this one, last element from this one. Okay, it's fine. Let's do this, submit. So this was our error, right? So that's all for today. If you like this video, please hit subscribe so that we will you will get more videos like this, right? Now let's understand about complexity, okay? So as you can see, if we will take the length like this and this one, right, spell dot length as a m, and portion will take m, right? So both, you see, we are going both, right? In which first of all we'll do sorting, so it will take m log n, right? Or so you can say this is for portion, so we'll take m, so it will take m log m, and for this one it will take n log n, right? And for that we can say o m plus n log n we will take, and for this one, right, we are taking the space, so we'll take o of m, because we are storing also the value into the result. Okay, that's all for today. Thank you guys, thank you for watching this video.